I'm going to discuss a formula for finding the averages of functions with respect to intervals. Okay, let me state that formula right now. If you want to find the average of f of x with respect to x values between a and b, you would use the following formula. All right. Now you might be wondering, why do we need integration to calculate something as simple sounding as an average? There are different types of averages. When you calculate the average age of the members of your family, you're calculating the average of a finite set of numbers. If your teacher ever told you the average exam score for a given exam, he or she was telling you the average of a finite set of numbers. Notice that there is an unlimited number of potential x values between a and b. You see the difference? All right, now let me try to give you some understanding of where this formula came from. So let me first draw a picture that corresponds to the integral. Okay, so the integral is equivalent to the area, or corresponds to the area of the yellow shaded region. All right? Now, this is important. Would you agree that somewhere in the world you might be able to find a rectangle that has the same area as the yellow shaded region? All right? Think about that for a moment. In fact, for any region, okay, for any area, you can find some rectangle somewhere that has the same area as the figure's area that you're interested in. Okay, so let's think about what that rectangle would look like that has the same area as the yellow shaded region. Okay, let's make a few attempts. So let me draw a rectangle resting on the x-axis with the same width as the yellow shaded region. So that green rectangle has an area that's too small. Notice that that green rectangle has a height equal to the minimum of f of x with respect to the given interval. Let me try again. So that second green rectangle has too large of an area. Notice that that rectangle has a height equal to the maximum of f of x with respect to the given interval. All right? So apparently we need some rectangle that has an area in between those two areas. How about something like this red rectangle? Okay? Now, in a sense, can you see that in a sense the height of that rectangle must be the average height with respect to the function and the given interval? Okay, so if you can see that, if you can accept that, then we could get to the average formula that I have there in the black box. Okay, so let's assume that the height of that red rectangle corresponds to some function value f of c for some c value, okay? And we can calculate the area of that red rectangle using its length and width, okay? So we would get b minus a times f of c. Okay, now we're assuming that that's equal to the area of the yellow shaded region, which is given by the integral from a to b of f of x. So let me set those equal to each other. b minus a times f of c is equal to the integral from a to b of f of x. Now let me divide both sides by b minus a. And what do I get? So lo and behold, I got the average formula. Okay? The average, I got the expression equal to the average formula in the box. Okay? So that's my attempt to give you an intuitive understanding of where this average formula comes from. All right? Now, let's do some examples. Suppose I wanted to calculate the average of f of x equal to x with respect to x values between minus 1 and 1. So to do that, using my average formula, I would simplify the following expression. So that would give me that, and continuing, I would get 1/2 minus 1/2, not minus negative 1/2. So I would get 0. All right, so apparently the average is 0. Now you can see that if you think about the graph of this function, it has just as many points above the x-axis as below. It has just as many function values that are positive as values that are negative. Okay? Now let me have you try one. Would you please calculate the average of g of x equal to x squared with respect to x values between minus 1 and 1? All right, so pause the video and do that now, please. All right, I'll go ahead and do it. So we need to simplify this red expression. And that would give us 1/6 of 1 cubed minus minus 1 cubed, which is 2/6, or 1/3. All right? I hope that's the answer you got. Okay, now I'm going to show you a hopefully somewhat interesting example involving a trig identity. And we'll close with this one. Suppose you wanted to calculate the average of h of x equal to sine squared x with respect to x values between 0 and pi. Okay, so you would set up the expression to simplify. And at that point, you might be stuck because you may not know how to calculate the antiderivative of the sine squared of x. All right. However, you may remember from trigonometry that that's equal to 1/2 minus 1/2 times the cosine of 2x. Okay, so you can happily go ahead and calculate the integral, the expression on the right side of that equation, and that would give you the necessary answer. All right, so finding the antiderivative of the cosine of 2x would involve u substitution. Okay, I invite you to work that out. I'll tell you the answer you would get, but I won't work it out right now. But you will get when all is said and done, 1